Hi, in this video we are going to discuss about assessment brief of algorithm designing and analysis. This is a presentation. So we will directly jump into the presentation slides. So in this we are going to talk about serverless approach for cloud resource allocation and cost minimalization using edge devices. In this here I had included an acknowledgement. Up next, its agenda of the presentation. We will look into the abstract introduction, literature review, proposed solution, and block diagram, as well as flowchart, and we will move on to the conclusion and see some of the reference. Let's get started. So, in the abstract, we may discuss about the rapid evolution of serverless edge computing that create opportunity for low latency and cost efficient execution. Since the load pattern is unpredictable, budget constraints and strict automation orchestration mechanism is lacking, we used to propose a hybrid intelligent resource management system that actually helps to bring cost efficiency and understanding the system in dynamically and multi-node task assessment. This use a machine learning technique as well as it use a deep reinforcement learning and stability driven optimization principle that actually helps in scalable solution and integrated resource management. In introduction, we are going to see the serverless computing has become one of the most important paradigm in the modern cloud architecture. It's because it's on-demand services. Apart from this, pre-professional resourcing and unforeseen operation cost and environment addressing challenges are the major cause of data-driven approach. So in this, we are proposing a hybrid approach that actually serverless platform, emerging application like autonomous system, smart cities, and IoT analysis increasing dependent on edge computing. So latency and data locality requirement will be solved using this methodology. Edge computing extends a computational capability and end user and device reducing latency and bandwidth consumption. This increase the way of using cloud and edge in an efficient way with a great cost management methodology. Workloads change dynamically and making it hard system to reach optimal performance and cost efficiency without intelligent decision mechanism. Most existing cloud platform lack of comprehensive support of multi-node deployment, automatic function placement, and cost aware of scheduling in this distributed edge devices. The key overview of challenge that enable serverless function, it's migrate automatically between cloud and edge resource. So this is the major breakthrough of real-time scaling condition, a hybrid intelligence system that can manage the resource with switching from cloud and edge devices according to the load intake and latency identification. In literature review, I had identified few of the gaps in three different papers. So let's get started. In 2025, Zhang team tried to something new that tackled resource management like it was a financial problem and deep dive reinforcement learning set up for function as a service DQN and paradigm function as a service, that POS system that helps to serverless system without wrinkling the budget. So deep reinforcement learning methodology helps in this method to handle a financial crisis and financial downfall of cloud deployment, where running high standardized program in cloud increases cost and switching from running routes and still landed results almost a good and high efficient way. This is Sang in 2025's identified problem and solution, while Cheng has identified in 2023 optimized for performance. There has existing a parallel line of research focused on uh, proactive resource management, where intelligent resource management helps to reduce the cost as well as space, uh, latency, and other form factors that we discuss later. Ali in 2024 introduced a dynamic scaling framework using random forest modeling, where that reinforcement learning helps to identify if there an existing load incoming to the server and make a decision of auto scaling with the edge devices in a cost efficient way. And cloud domain consider complex multi-node placement requires true edge computing landscape. So in this approach, Ali and Sang and Cheng has three different identified problem statement where they can solve these issues very successfully. So I had identified a gap that we will discuss in the proposed solution in the next slide. So in this proposed solution from whole three papers, we have came to a conclusion that we can combine deep reinforcement learning framework and a hybrid intelligent orchestrator to make a good decision making and best size memory management and latency reduction by deploying our code in edge devices when they face a crisis in high load. This is the block diagram of a proposed solution where we deploy the GitHub code, and we will identify using a CI/CD pipeline through a web API. Whenever a web API find a high level of load from a client request from different devices like PC API integration, IoT bots, app and API, and graphical integrated APIs, it will automatically redirect and ask help from HIRM orchestrator, that is an intelligent decision making system where it helps to deploy the code in edge devices from the code base, that's code base itself in the GitHub. So each node consists of a strong functionality of Azure function, for an example, like web services and webhook, and high uh, functionality to n number of nodes that connected to the edge devices. So it's solving the problem and redirecting it into the edge devices. This is how the problem will be solved and efficiently will be maintained in a high manner. These edge devices have a flow of execution that we have shown in this flow diagram, that initiate the system with the API call and identifies a workload using random forest machine learning algorithm with a predefined data set, and it will go to the distributed load edge device proximity policy optimization algorithm PPO, where this identifies the reinforcement learning methodology again with a deployment task considering cost efficient way. And next it will jump into the deep deterministic policy gradient to identify best edge node to be deployed, where the which best edge device can solve this problem, and it will deploy into the edge devices. So there are n sum of n number of edge devices, so it can deploy into anyone, whereas the W and H denotes the workload, and weightage and feature metrics. H denotes the feature metrics and W denotes the weight of the feature metrics, where this belongs to a heuristic threshold and handling in edge avoid rapid development of cycle, where if there any deployment and removal of the code happens regularly, it will handle it efficiently, and it will go to the track metrics, and it will take a trend metrics analyze, and it will stop the code. Up next, the conclusion. This project presentation unified intelligent resource management framework and edge device optimization, where the research gap in itself identified three different scalable solutions that can be combined and enable a low latency and high responsive throughput engine. That's my proposed solution. And Thank you. Here are the few reference where I took from.